Уважаемые дамы и господа, предлагаем вашему вниманию 6-й юнит учебника «Импакт 3», дословно переведенный и озвученный для вашего удовольствия под музыку и с ветерком.
Track 71, Unit 6, Activity 1. Listen and read.
We think of Earth as the blue planet and Mars as the red planet when looking at satellite images of them. Although they look very different, our home planet and Mars are actually similar in many aspects. Like Earth, Mars has its own atmosphere and clouds. Both planets have large, ice-covered areas called polar caps. Mars's landscape includes features also found on Earth, such as mountains, plains, channels, craters, and even volcanoes. Both planets have days that are about 24 hours long, and both spin on an invisible line called an axis. Each planet tilts to the side on its axis at an angle of about 24 degrees in relation to the Sun. This tilt is what causes the seasons to change on both planets. Astronomers have always wondered if life exists beyond Earth. If it does, our neighbour Mars is the most likely place to find it. Mars is a planet of wild extremes. It has the largest dust storms, the deepest and longest valley, the highest mountain, and the largest volcano known in our solar system. But to most planetary scientists, the biggest question is whether life is or was possible on the planet. Advances in technology have allowed scientists to equip robots with a variety of tools and then send them to explore Mars. These scientific instruments have been able to detect real proof that life is possible there. For example, one of the fundamental requirements for life, the existence of some form of water, has been discovered in several areas of Mars. A vast amount of ice is under the surface and also frozen in the polar caps year-round. In 2015, scientists confirmed that liquid water exists on Mars's surface. But will this finding lead to the discovery of life on the red planet? We're still waiting to find out.
Track 72, Unit 6, Activity 2. Listen and repeat.
Aspect. Some aspects of Earth and Mars are similar. Atmosphere. Gases in the air make up the Earth's atmosphere. Degree. Both Earth and Mars tilt on their axes at an angle of about 24 degrees. Detect. Scientists detected signs of water under the surface of Mars. Dust. Wind blows sand and dirt, causing a dust storm. Fundamental. Water is fundamental for all living things. Instrument. Scientific instruments have shown that water exists on Mars. Landscape. The landscapes of Mars and Earth are similar in certain places. Lead to. New technologies will lead to more discoveries on Mars. Plain. A plain is a large flat area of land. Proof. Scientists are looking for proof that life could exist on Mars. Satellite. Satellites in outer space help us to learn more about the planets. Valley. Mars has tall mountains and deep valleys. Vast. Polar caps are vast areas covered with ice. Wonder. People wonder if there is life beyond Earth.
Track 73, Unit 6, Activity 5. Listen to these words and match them to the definitions.
Astronomers have always wondered if there's life beyond Earth. Our neighbour Mars is the most likely place. Advances in technology have allowed scientists to equip robots with a variety of tools and then send them to explore Mars. These scientific instruments have been able to detect real proof that life is possible there. For example, one of the fundamental requirements for life, the existence of some form of water, has been discovered in several areas of the planet.
Track 74, Unit 6, Activity 5. Listen and repeat.
Advance. Technological advances have allowed scientists to study the landscape of Mars. Astronomer. Astronomers are looking for proof of life beyond Earth. Equip with. Scientists equipped the rover with useful instruments to study Mars. Requirement. One of the requirements for life as we know it is water.
Track 75, Unit 6, Speaking Strategy. Speculating.
Do you think that they'll ever find life on Mars?
Most likely scientists will research the topic for a long time.
I'll bet they're close to finding life.
It's likely that they'll first find microbes.
What if scientists really do find evidence of life?
I'm fairly sure that will change everything.
Track 76, Unit 6. Activity 1. Listen. How do the speakers speculate? Write the phrases you hear.
Do you think people will ever live on Mars?
Well, it's likely that people will travel to Mars. Most likely they would only stay for a little while though. I don't think people will be able to survive there for very long. The atmosphere is too thin, much thinner than Earth's.
It's true, but I'll bet that they'll develop the technology needed to survive in that atmosphere. Maybe scientists will make special suits that we can all buy and wear to live on Mars.
Possibly, but it's likely that the suits would be very heavy and expensive, and you'd probably never be able to take them off.
Yeah, I guess I'd rather wear jeans and t-shirts here on Earth. But what if they make it possible to travel to Mars?
I'm fairly sure that only a few people would want to go. It's a big risk, and it would take a long time.
Yeah, but would you go? I think I would.
I don't know. I think I'd rather just follow the Curiosity rover's mission from the safety of my own home.
Track 77, Unit 6, Grammar. Present and past conditionals. Talking about unlikely but possible or impossible situations. Unlikely but possible.
If I were a scientist, I would focus my research on Saturn. He would be a space tourist if he had the money.
Impossible.
If I had known there was a talk about Mars, I would have gone. They could have fixed the rover if they had equipped it with better tools.
Track 78, Unit 6, Activity 1. Listen. What's the reality in each case? Tick the box. 1.
If I were president, I would expand space exploration programs.
2.
The project would have succeeded if there had been money for new equipment.
3.
If it had been my choice, I would have investigated Saturn's moon Titan.
4.
They would build a second orbiting space station if they could.
5.
We would have repeated the experiment if we had had the time.
6.
If I were you, I'd choose some kind of career in space exploration. Track 79, Unit 6, Activity 3. Look and listen. Learn about Saturn's moons, Titan and Enceladus.
Of Saturn's 62 moons, the two most habitable for human life are Titan and Enceladus. They are very different from each other. For example, Titan is the second largest moon in our solar system, with a diameter of 2,575 kilometers. Tiny Enceladus has a diameter of only 500 kilometers. The atmosphere on Titan is thick and hazy, hiding surface features from most scientific instruments. Only its seasonal storms are visible. In contrast, the atmosphere on Enceladus is very thin. This means there is no air pressure or weather. However, scientists are better able to see what's happening on its surface. Each of the moons has a unique feature as well. Titan is the only other place we know of in our solar system with liquids flowing across its surface. Enceladus doesn't have liquids flowing on the surface, but there are geysers sending icy particles and water vapour into the sky at a speed of nearly 1,300 kilometres per hour.
Track 80, Unit 6, Activity 3. Listen and repeat.
Diameter. The diameter of a circle is equal at all points. Geyser. A geyser is a hole in the ground that shoots out water and steam. Habitable. Scientists believe that 2 of Saturn's moons could be habitable. Hazy. A hazy sky is hidden by clouds and dust. Seasonal. Seasonal changes include variations in temperature and the amount of sunlight.
Track 81, Unit 6, Activity 2. Listen and repeat.
Aspiring. An aspiring astronaut wants to travel in space one day. Background. Astronauts need to have a background in maths and science. Chance. Alyssa Carson had the chance to go to space camp. Leadership. A successful space mission takes patience and strong leadership. Perseverance. If you have perseverance, you're determined to reach your goal.
Track 82, Unit 6, Activity 3. Think about the different categories that the information can be organised into.
More than a dream. Could space be your own new frontier? Are you one of Earth's next generation of explorer astronauts? What do aspiring astronauts do to prepare for the possibility of a career in space? A good person to ask would be Alyssa Carson. Her dream is to be the first person on Mars. As a child, Alyssa read as much as possible about Mars, studied its maps, and did everything she could to learn about the red planet. This included going to a space-themed camp for the first time at age 7. Since then, Alyssa has attended more than 20 such camps. In fact, at age 13, she was the first person ever to complete all the NASA space camps in the world. At these camps, future astronauts get the chance to ride in spaceflight simulators and experience what zero gravity feels like. While space camp may not be possible for everyone, there are many other ways to prepare for a future in space. If you're interested, consider the following. Astronauts must be in excellent physical condition. Now's the time to begin a healthy lifestyle of a balanced diet, regular exercise, and plenty of sleep. Astronauts need to meet a wide range of physical challenges. Skills acquired through activities such as scuba diving, skydiving, skiing, mountain climbing, and piloting aircraft are extremely valuable. Now's a great time to start learning these types of skills little by little. Astronauts need to meet a wide range of emotional challenges. Work on developing positive traits such as patience, cooperation, and perseverance. Take every opportunity to practice team building, leadership, and problem-solving skills. Astronauts need to have a strong background in maths and science. Work with your school's advisors and mentors to determine the best subjects to study. Keep up with real-time developments and discoveries in space. Don't forget languages. In addition to English, you'll need to know other languages, such as Russian and Chinese, to communicate successfully.
Track 83, Unit 6, Grammar. Adverbs. Comparing how things are done.
The new satellite transmits data efficiently. The last satellite didn't transmit data as efficiently as the new satellite. The new satellite transmits data more efficiently than the last satellite. The new satellite transmits data the most efficiently of all the satellites.
The new rover travels fast. The last rover didn't travel as fast as the new rover. The new rover travels faster than the last rover. The new rover travels the fastest of all the rovers.
Track 84. Express yourself. Activity 1. Read and listen to a scene from a film script about a team of space explorers.
Fade in, exterior spaceship in orbit around Mars. Fade to, interior spaceship main control room. Night. Mark and Sonia, with torches on, come through the doors and stop in front of a bank of dimly lit active computer screens.
Okay, we're here alone. Now, show me what you're talking about.
Look at screen 17. Something strange is going on.
No, I don't see anything unusual.
Look at the top right corner.
Mark catches his breath. as he leans in to examine the top right corner of the computer screen, turning to look wildly at Sonia.
That's impossible.
I know, but it's there.
I can't believe it. We need to wake up the mission commander right now.
Sonia puts her hand firmly on Mark's shoulder.
Don't panic. We need to think.
Are you joking? What's there to think about?
Sonia takes a deep breath. Then she looks directly into Mark's eyes.
Mark, I don't trust him.